your thinking caps and let's hit it.
Let's go through the first two steps really slowly this time because I don't know.
Okay.
How
All right. So, no, we didn't do this one. I don't think we did this one.
I guarantee I wrote them down.
Maybe not.
Okay, so let's pick out. Let's maybe make a drawing here, and you got to do a careful drawing on some of these. Okay, so let's see. We've got a. I'm going to be really tricky on this one. Okay, this ice is going to be, I don't know what color it is. It's going to be orange ice. I'm not sure why.
Oh, Tom Hanks.
Wait, hey, there's a movie on Tom Hanks.
If Eric Boyle was an actor, he'd probably.
He actually is an actor.
Yeah, haven't you seen Pretty Woman?
Yeah, and haven't you seen football Princess Quarterback? What is that?
Quarterback princess. It's
Quarterback.
Were you the quarterback?
No, I wasn't personally.
I'm sure you were.
No.
Oh, somebody played.
Helen Hunt was the quarterback princess.
Did you meet Helen Hunt?
I did.
Really?
Yeah.
How? Were you in
Okay.
it?
Yeah.
Yeah.
I'm all over it. I was a high school student walking through the halls.
You
Yeah.
filmed it in your high school?
Yeah.
You
You
get
get
paid?
money every time
Yeah.
you play?
I got paid money and I got all the free food I could eat. It was great. Okay, so here we go.
He doesn't lie. Like,
Spherical iron ball, 6-inch diameter, is coated with a layer of ice of uniform thickness. Okay. If
Watch
the
that movie now.
Shh.
okay, rough topics.
Geographical ball as well
I
as.
didn't know you were involved in that movie.
No.
Everybody should.
That'll be hard to miss.
All right. So if the ice melts at a rate of 13 cubic inches per minute, how fast is the thickness of ice decreasing when it is 2 inches thick? Okay. So we need to get some. Here's our picture, right? But we need some variables. Now the ice is frozen around this iron ball. So
We know
let's
radius.
attach some variables to this now.
We
So
know
this
R,
is
we know V dot.
okay. Good. So our snapshot variables. We know what is this right
V
here?
dot.
V dot. Okay, but now look here. It says the ice is melting. So what's that tell you about V dot? It's negative. We're losing volume. So negative 13. And what else we got? Now, okay, the thickness of the ice is 2 inches, but we got to be careful with that because that's just this part right there, right? This sphere that we're looking at here, we're thinking of from the outside. Let me ask you this: from the outside, could we tell if this were solid ice or if it had iron in the middle? Couldn't really tell, could you? I mean, as far as we're concerned, it looks like a solid ball of ice, and it's really kind of tricky in a way that there's this iron piece in the middle, right? But taken as one continuous sphere, we've got to go through the radius of the iron first, and then the thickness of that shell of ice, right? So really, R ought to be that measurement right there, shouldn't it? Okay, so how far? What is R then? 5. Good. Because the inner radius is, that distance is 3, right? And they're telling us that this distance is 2. So the whole thing is 5.
Where does it say that that distance is 3?
Doesn't it say that? Yeah, it's 6-inch diameter. Okay? So 3-inch radius for the iron, 2 inches of ice.
Oh, okay.
So we get R equals 5. And then we want to know, now this one is really pretty tricky. There's some things you got to be careful of here. It's a good question. But they want to know how fast is the thickness of the ice decreasing when it's 2 inches thick. So R is 5. What are we looking for here? R dot.
Bam.
Okay, so what's our static equation then? It's a volume of a sphere, right? So if we ignore the dots, what are we doing?
It's either pi r squared or 2 pi r. Remember.
So what is it? What's the volume of a sphere?
4/3 pi r.
4/3 pi r cubed, okay? And so then step 3 would be the calculus. If we implicitly differentiate, what are we going to get?
Where did I write down this?
Good.
You don't know either.
Okay, make sense? Okay. And then all we want to do here, so there's step 3. Step 4, we're just going to isolate our dot, right? And plug and chug. Okay, so if we isolate our dot, what are we going to get? So if we plug in the values, that's negative 13 over 4 times pi times 5 squared, which is what? Negative 13 over 100 pi? Okay. Right? So that's our exact answer. Now, but how would we answer this? It wants to know how fast is the outer area, how fast is the thickness of the ice decreasing then? Okay, it's negative because it's decreasing, right? But if they want to know how fast, it's the magnitude of that, isn't it? What we're looking for is really just that part. Okay? They want to know it's like saying speed versus velocity. Okay? So there's part A. Now part B. Part B is going to be pretty simple because we already know all the important stuff. We can add, for part B, because we now know the value of our dot, we could essentially add that to our snapshot. At that frame of the film, that's how fast the radius is changing. Okay?
Wait, that's
Right? That's the answer for part A. Part B, they want to know how fast is the outer surface area of the ice decreasing. Right? So then we're going to shift over to surface area, which is what for a sphere? Okay, and if we want to know how fast that's changing, what quantity are we trying to find? S dot. Okay. So S dot then is just 4. Well, what is it? You tell me. Sorry, not 4. 8. Bring the 2 down. 8 pi r dot, which is 8 pi times 5 times that, which was negative 13 over 100 pi, right? So that's going to give us negative 520 pi over 100, so negative 52 over 10 pi, is that right? Okay. And the pi's cancel, so negative 52 tenths. If I did my arithmetic right, which I can't guarantee I did.
And you have to
Right, okay. So, and they want it as a decimal, or what do they want? Okay, so then we'd make it 26 fifths. But they also, how'd they word it again? They say, how fast is the outer surface area of ice decreasing? So it would be the number part, the magnitude. So 26 fifths. And then what would the units be? You tell me, if we look at the original question. So the answer to the first part would have been, the change in the radius would have just been inches per minute, right? Now what about the surface area? What would the units be for surface areas? Yeah. So we would have had square inches per minute, right? Make sense? Okay. All right. Very good. the length L of a rectangle. Okay, this is pretty good. I think this might be it then for the whole ball of wax, and then we're good to go. So we need a picture here. So for our snapshot, the length L of a rectangle, so there's L, is decreasing, or is increasing at this rate, while the width, W, is decreasing at that rate. Okay, they give us two values, and they want us to find the rates of change of the area, the perimeter, and the lengths of the diagonals of the rectangle, determining which are increasing or decreasing or constant. Okay? So let's start off with the first part here. Now we know, let's write down the snapshots first, snapshot variables. So W, in our snapshot, W is what? Let's see, 12. L is, what else do we know?
L dot.
Okay, what's L dot? 7, okay. And W dot? -7. Okay. So if we're wanting to, for the first part of this, if we want to find the rates of change of area, what's the area of that rectangle? WL, sure. Okay, so, right, if we want to find the rate of change of area, what is that? A dot. So all we're doing is just differentiating, right? What's A dot?
L W dot. Plus W.
Okay, by product rule. Good. And we know that stuff. So we can just plug that in. So that is, let's see, 7 times -7 plus 12 times, is that right? 12 times 7? Did I get that wrong? I think I did. No, 5. That should be 5, shouldn't it? Yes.
W dot is,
Yeah.
Plus 12. Yeah, that's a negative. Let me make that better. Okay, 12 times 7? Yeah. Okay. Which is what? -35 plus 84, so 39? No, 49? Positive 49 is A dot, right? Okay. So is that increasing or decreasing? Increasing. It's positive, right? Okay, next part. They want to know how is the perimeter changing? What's the rate of change of the perimeter? Okay, well, what's our equation for perimeter?
2L.
So, what's the rate of change of perimeter in P dot?
2L dot plus.
Okay, which is, I can factor out a 2, right? So I just get 2 times 7 minus 7. 0, right? So the perimeter is staying the same. Makes sense, doesn't it? If we're gaining width as fast as we're losing length or vice versa, then the perimeter is going to stay the same. So what's that tell you if P dot is 0? Constant. Yeah, it's not changing. It's staying constant. Good. Okay, and then last one, we want this diagonal. Right, so if we want to get that diagonal, go away. Okay, so if we want the diagonal there, we just got a right triangle, right? And so we'll call the diagonal maybe D. What's going to be the formula for D?
Square root of L dot.
Yeah, good.
Square.
Okay, good. So we could say D equals the square root of L squared plus the quantity L squared plus W squared. Or if we want to, we could even say, well, that's fine. We can just do it that way. We could also say d squared equals L squared plus W squared, and just differentiate that implicitly. We'll get a D in our answer, but D is that square root we were talking about. Either way, same thing. See what I'm saying with that? We could either, yeah, I'll show you. So we could either do this, or we could square root both sides and get D equals the square root of L squared plus W squared. Honestly, I think it's probably a little, yeah. Okay, but can you have a negative length of a diagonal? Because it's a length, we only take the positive. And you're right, mathematically it's plus or minus, but we would discard the negative because it doesn't make physical sense or geometric sense in that picture. So for the perimeter, say it again. Yeah, constant, right? Because P dot's 0. I think it'd be a little easier just to do this, because we have D defined there. So if we implicitly differentiate over here, what do we get? 2 equals
2L.
right? And so on the other side, then we would just get, if I get rid of the 2's, if I divide everything by 2, I just get D dot equals L dot plus W dot. So D dot is just L dot plus W dot over D, which we know is that square root we defined, right? So that's just equal to L dot plus W dot over the square root of L squared plus W squared. Okay. And we just plug stuff in there, right? And get an answer. Because we know those.
Units.
Make sense?
You didn't make it more than insurance.
I didn't.
Just picture you.
Right. Okay. All right. Any other questions? Should we go work? Sure. All right. Let's hit down. You know, rotate ever on and on. Head down and pull out.